Hey folks!
It's time for Maths with Mr. Thomas.
Thank you for the picture, Mahiba. It looks just like me. Here we go with chapter 3, lesson number 3. We're moving on now in the straight line chapter to look at the gradient formula. Woo! What's the gradient? Good question, Tracy. The gradient of a straight line is a measure of its steepness. Oh, thank you. And if we have a straight line, we can measure the steepness or the gradient of the line by Amanda McInnes. Help us out. You are perfectly right. What you do is you take the vertical distance and you divide that by the horizontal distance. So, the gradient is a measure of the steepness and it's the vertical distance divided by the horizontal distance. Let's take that we learned in National 4 a little bit further. Imagine if this time we are given a couple of points on a coordinate diagram. Something like that. You can see we have this red line here. It is a straight line and it is joining this point here to this point up here. The points are just a little bit bigger so you guys can see them. We have the x and the y coordinate for this point. So this might be, for example, 3, 2. All that it means is this 3 is how far we came along in the x-axis, and the 2 would be how far up we are going in the y-axis. The other point, we could call that anything at all. Let's say that was 7, 9. What that means is we would have an x-coordinate, and we would also have a y-coordinate as well. So we've got an x value and a y value for both of them. Rather than put in numbers though, you can see I've just called them x and y, and this one as well is x and y. Because I've got 2 points, it's going to be confusing if I call them both x, y. So what I've done is I've called one of them point 1, so I've put an x1 and a y1, and I've called the other point 2. So I've put an x2 and a y2. If we are looking at the gradient, well, it's the steepness of this line, and it is just the vertical distance, so the length of this black dotted line here. But we could actually work that out because we've got these 2 points. And the vertical distance is just going to be the difference between y2 and y1. So what we can do is we can take y2 and then take away y1. That'll give us this vertical distance. For the horizontal distance, Amanda's mum Jackie, what would you do with this one? Perfect! You would have x2 take away x1. So you would take this x value and you would take this value away from it. So that'll be x2 take away x1. Woo! That is what you're doing. Which means we can change our formula ever so slightly. Because if we have these 2 points, x and y, remember, call one of them point 1, so x1, y1, and the other one point 2, x2 and y2. If we change our formula from vertical distance over horizontal distance, what we've really got, well, the vertical distance, Amanda, remind us? Good, it is y2 take away y1, and Jackie, good, x2 take away x1. High five to you both. Woo! Let's try a few examples then of working out the gradient of a straight line. So, example 1, calculate the gradient of the line joining point A, which has the coordinate -1, 3, to point B at 7, 5. We are going to be using our gradient formula, y2 take y1 over x2 take away x1, so we can write that out. M is your gradient, and I've put AB here. So it's the gradient of AB. The first thing I would do is write the points down just at the side. So we have A and B. Remember, we have in each point an x value and a y value. So we've got x and y, and the other point as well will also have an x and a y. It's alphabetical, x comes before y. Call one of them point 1, so I've got an x1 and a y1, and call the other one point 2, x2 and y2. If you number them back to front, so if you called this one x1 and y1, and this one x2 and y2, it would make no difference whatsoever to your final answer. You would still get the same answer and the same gradient. Doing it this way though, we would end up with, if we start subbing the values in, Daniel, help us out. Good, you would have y2 take away y1, which would be 5 take away 3, over. And then what would you have at the bottom, Daniel? 7 take away -1. Well done, Daniel. 7 take away negative 1. What happens, Daniel, when you take away a negative? You add! You do indeed, you would add. Woo! So you'd have 7 take away 3 over 7 plus 1. So we would end up with 5 take away 3 is 2, 7 add 1 is 8. We end up with 2 8s. Make sure you always give your answer in its simplest form. Daniel, finish this off. You would get 1/4. Well done. 1/4 would be the gradient of that line. Woo! You can have a high five as well, Daniel. Example 2, calculate the gradient of the line joining point C at 9, 2 to D, negative 2, 8. Once again, start this off by writing the points at the side. So we've got point C and we've got point D. Remember, with point C, we have an X value and a Y value. Remember, it is alphabetical. And point D would also have an X and a Y value. Alphabetical. So this one we're going to call point 1. This one we're going to call point 2. So we've got an x1 and a y1 and an x2 and a y2. Remember, if you number them back to front, if this became 2 and 2 and this became 1 and 1, it makes no difference to your final answer. We are wanting to work out the gradient of the line CD. So we've got MCD, and that would equal, remember, your gradient formula, y2 take away y1 over x2 take away x1. Perfect. So start subbing in the values. Y2 is 8, Y1 is 2, so we would have 8 take away 2, and that would be over negative 2 take away 9 with X2 take away X1. Start to work that out. 8 take away 2 is obviously 6. Negative 2 take away 9. Well, imagine it in terms of temperature. If the temperature was negative 2 degrees and it dropped down another 9 degrees, it would be freezing. But it'd be negative 11. So we would have 6 over negative 11. We can, if we want, instead of the negative being at the bottom, you could always take that out to the side. So you could have negative 6 11ths. Or if you wanted, you could also put the negative at the top with negative 6 over positive 11. It doesn't matter where the negative is, at the bottom, at the top, at the side, as long as your answer is negative. What does it mean if your gradient is negative? Brilliant. It means your line is going to slope down from left to right. So if you imagine it on a coordinate grid with an x-axis and a y-axis, if they were drawn in, your line would be coming down the way. Woo! Looking something like that. As I said, these 2 points, if you write them back to front and you call this one point 1 and this one point 2, what you'd end up with is instead of 6 over negative 11, you would have ended up with negative 6 over positive 11. But you can see it's the exact same thing. It's 6 11ths and it's a negative. So it makes no difference which point is point 1 and which point is point 2. Let's try another one. Example 3, Mahiba. Are you ready for this? Calculate the gradient of the line joining point E with the coordinates negative 1, 5 to point F with 3, negative 15. Here we go. E and F. Write down the coordinates first of all. Just remember what you do is you call one of them point 1 and one of them point 2. But before you do that, you would have an X value and a Y value for each point. Again, it's alphabetical. So you would have X and Y. And with F as well, you would have X and Y. It's alphabetical. So this is going to be point 1, just because that's when I'm making point 1. So I've got an X1 and Y1. And this one is point 2 with X2 and Y2. We are working out the gradient of the line EF. So I've got MEF. To show I'm working out the gradient of EF. And once again, I use the gradient formula. Marley, the gradient formula is y2 take away y1 over x2 take away x1. Marley, perfectly right. Chloe, if you sub in the numbers, you would have, good, negative 15 over 5. You are perfectly right, because that's y2 take away y1. And with x2 take away x1, you would have, good, 3 take away negative 1. Woo! So, negative 15 take away 5. I'm just going to leave that as it is for the second. But I've got 3 take away negative 1. Rejwan, master of negatives. What do you do when you subtract a negative? We add, Mr. Thomas. You do indeed. Well done, Rejwan. So that becomes 3 plus 1. Yeah. We would end up with negative 15 take away 5, which gives us Negative 20. Good. And 3 add 1 is 4. Good. Would we leave it as negative 20 over 4? No. Why not? Because we can simplify. If you simplify negative 20 over 4, you would end up with, well, 20 divided by 4 is 5. But we've got a negative and a positive. If you have a negative and a positive, your answer will end up negative. So we've got negative 5 for our gradient. Once again, if you imagine this with an x-axis and a y-axis drawn out, if we end up with a negative gradient, what does it mean, Hassan? Good. It would mean that the line is sloping down from left to right. Woo! Next one, example 4. Calculate the gradient of the line joining point G at 7, 1 to point H, negative 8, 1, and then describe the line. Ooh, fancy. Start off once again by writing down the two coordinates. So we've got G and H with 7, 1 and negative 8, 1. And once again, we have our X and our Y value for each point. Remember, X, Y, Z, it is alphabetical. You've got it. So we've got X and Y. Call this one point 1, so X1 and Y1. And let's call this point 2 with X2 and Y2. Alphabetical. So from here we want the gradient of the line going from G to H, or we could have HG as well. It's the same line going from G to H or H to G, and it's still using the formula. Go on, Harry. Brilliant. Y2 take away Y1 over X2 take away X1. Well remembered. Bet Hoddy wouldn't do that. So we sub in the values. Y2 take away Y1, Y2 take away Y1 would be 1 take away 1, and that would be over negative 8 take away 7. Bum bum bum! Adam, I see you waving around like a madman. What's wrong? We would get 0 on the top. You would, because if you do 1 take away 1, you end up with 0. And negative 8 take away 7. Again, think about it in terms of temperature. If the temperature is negative 8 degrees, if it goes down by another 7, you would end up at negative 15. Woo! If you have 0 divided by negative 15, that would give you, it does give you 0. You are perfectly right. Good. We end up with 0, which means, well, a line with 0 gradient is just going to be a perfectly flat line. It is not going to have any vertical height whatsoever as you move from left to right. So since the gradient of 0, the line is horizontal. Woo! We are asked to calculate the gradient of the line and then describe it. Well, that's your answer. It's going to be a horizontal line. Because it's going to be a horizontal line, it means the equation is just going to be of the form y equals, if you're looking at the equation of that line. Notice here we have for our y value, we've got 1, and this y value is also a 1. Always have a look to see if either the x values or the y values are the same. If you did have to take it a little bit further and you were asked for the equation of the line, if you ever end up with either the x values being equal or the y values being equal, the equation of the line will just be x equals whatever that number is, or y equals whatever that number is. Here, because it's the y values that are equal, the equation of that line would just be y equals the 1. Woo! Next one. Example 5. Calculate the gradient of the line joining point K to point L. K is at 3 and negative 3, so let's write that out at the side. And L is the point 3, 4. Let's write that out at the side. Just remember, when you do this, you have for point K an x value and a y value. It's, you got it. And for L, you've got an x value and a y value. Again, it's alphabetical. Good. So we're wanting the gradient of the line joining K to L. So we've got M, K, L. And that would equal, what is the gradient formula, Camille? Y2 take away Y1 over X2 take away X1. Very well done, Camille. Aline, start subbing in the values. What would you end up with? Well, we've got Y2 take away Y1, so we would have 4 take away negative 3. Because I'm taking away a negative, I'm just going to shove that negative in brackets. Get into those brackets. And we've got our X2 take away X1, so X2 take away X1 would be 3 take away 3. Woo! We have 4 take away -3. What happens when you take away a negative? Rejwan, master of negatives, tell us, what would you do? You add. You do indeed, Rejwan. So that would be 4 plus 3. And this time we are dividing by Adam. Again, you're waving around like a maniac. What would you have? 0. Brilliant. So we end up with 7/0. Bum, bum, bum. Adam, what do you get if you do 7 divided by 0? No, it's not 0. If you try it on a calculator, if you try dividing by 0, it doesn't work. You end up with an error message. So that is just going to be question mark. But we're not really looking for a gradient of question mark. What would you say? Well, if you end up dividing by 0, it cannot be done. It's impossible to divide by 0. You end up breaking the world. So what you would say is that the gradient is undefined. It's an undefined gradient. Always remember what the gradient means is if you've got your line, it's the vertical distance divided by the horizontal, and it's a measure of the steepness. However, if we have just a vertical line to begin with, well, it's got 0 horizontal distance. So that's why we would have the vertical, the length of the line divided by 0. It can't be done. And it means for every 1 unit we're coming along, well, we don't have any height because we're not moving along to begin with. So what it says is that the line is therefore a vertical line. So if you end up with something divided by 0, it can't be done. The gradient is therefore undefined, and it means the line is vertical. If you were asked to go a little bit further and get the equation of that line, well, for the equation of the line, always have a look to see if either the x values or the y values are equal. Here, you've got an x value of 3, and also over here, you've got an x value of 3. These two x values are equal. If the x values are equal, the equation of the line is therefore x equals whatever that number is. So it's just going to be x equals 3. If I flick back to the last page for a second, here with this one, you saw the y values were equal. They both had a value of 1. The y1 was 1, y2 was 1. So the equation of the line was just y equals 1. Here, in this example, the x values are the same. They're both 3. So the equation of the line would just be x equals 3. But as I said, that's taking it a little bit further to look at the equation of the line. What you need to know just now is, again, if I flick back, if you end up with a gradient of 0, so if you have 0 divided by some number, then the answer is just 0. We could have 0 divided by -15, we get 0. That means you're going to have a horizontal line. If, however, you end up dividing by 0, well, that can't be done. And if it can't be done, it means the gradient's undefined. And if it's undefined, then it's a vertical line that you would end up with. Let's try one more example. Example 6, given the gradient of the line joining point P, -3a, to Q at -113, well, because that gradient is 4, calculate the value of a. Once again, whenever you get one of these questions that's to do with the gradient of the line, write down those 2 points. So we have point P, -3a, and we have point Q, -113. What should you do after that? Brilliant, write down x and y, x and y. Remember, it's alphabetical. So, with point P, we've got an x value and a y value, and with point Q as well, we've got an x value and a y value. Call one of them point 1, so I'm just going to call this one point 1, so x1 and y1, and I'm going to call this point 2, so we've got an x2 and a y2. We are wanting the gradient of the line PQ. Well, not really. We are wanting to find the value of a, but because this is all to do with the gradient of the line joining those 2 points, start off writing down the gradient formula. So the gradient of PQ would be y2 take away y1 over x2 take away x1. However, what it says is the gradient is what? 4! Good, so we know that equals 4. So the y2 take away y1 over x2 take away x1 would equal 4. It tells us that here, the gradient is 4. So when you sub the values in, it's still going to be equal to 4. When we sub the values in, so y2 take away y1, well, in this case here, it's going to be 13 take away. We don't know what this is, we're calling it a, but just sub that in anyway. So it's 13 take away a. That would be divided by x2 take away x1, which is -1 take away -3. Again, because we're taking away a negative, to avoid having the signs touching, we would put the number in brackets. So we've got -1 take away -3. 13 take away a will just stay as it is, the 4 will stay as it is, but on the bottom if you have -1 take away -3, Rejwan, master of... Oh, here we go. What would you end up with? Brilliant, because you would have -1 plus 3. So we've got 13 take away a over -1 plus 3 equals 4. Where would you go from there? What do you think you would do, my belle? Brilliant. Here at the bottom you have -1 plus 3. And we know -1 plus 3 is 2. Good, so we can write that as 2. So we've got 13 take away a over 2 would equal 4. We're still wanting to find this value of a, but we've got 13 take away a and we're dividing it by 2. What we really want to do then is we want to get rid of this divide by 2. To get rid of that divide by 2, we can do the opposite. So we can multiply this side by 2. That way they will cancel out. However, if we do that, we would also have to times that side by 2 as well. Remember, it's an equal sign, so it's 2 sides. We have to keep both sides equal. We would therefore end up with 13 take away a. That divide by 2 would disappear because we're multiplying by 2. If you divide by 2 and times by 2, they just cancel out. But on the other side, we had to do 4 times 2. We would end up with 13 take away a is 8. From that, if you just cover up that value of a, just put your finger over it and then think, what number goes in there? Well, it's 13 take away something is 8. What would that something be? 13 take away what is 8? 5. Good. So we know that value there must be equal to 5. So a would equal 5. Again, if you know it's 5, you could sub it in and say, yes, 13 take away 5 is 8. So that works out. And that is how you find the value of a. Give these questions a shot. It's all to do with working out the gradient of a straight line using 2 points and the gradient formula. y2 take away y1 over x2 take away x1. Woo! Best of luck. Good luck, Amanda McInnes. Enjoy. See ya. Bye. Bye, Glasgow Academy. Bye, everybody. Bye. You can turn it off. You're still here. Bye.